Hello! In this problem, we are supposed to find the Thevenin equivalent circuit to the circuit left of the terminals A and B. This means that we need to determine the Thevenin resistance and the Thevenin voltage. I'm going to start with the Thevenin voltage. When we want to find the Thevenin voltage, we need to find the voltage on these terminals when there is no load. To do that, I'm going to use mesh analysis, which means I'm going to apply Kirchhoff's voltage law to this large mesh. I can't apply the Kirchhoff's voltage law to these two little meshes because there is this dependent current source and there is no way to know the voltage on the current source beforehand. So we need to apply the Kirchhoff's voltage law to the large mesh. How do we do that? So let's assign the mesh currents. This current is going to be current 1 and this current is going to be current 2. Now, according to Kirchhoff's voltage law, for this large mesh, we get now. We know that current 1 is equal to minus current x divided by 2. Now, how do I know that? Well, this current source provides 1.5 current x, and the current in this branch is current x, which means that the rest, the half of current x, has to go this way. So that's how we know that current 1 is minus current x divided by 2. And we know that current 2 is equal to current x. Now, if we substitute these two equations into the first equation, we get that now we determine the Thevenin voltage as the voltage drop on this 4 ohm resistor. So we get that the Thevenin voltage is equal to 4 times current X, which is 16 divided by 3, which means that the Thevenin voltage is 5.333 volts. Now we need to calculate the Thevenin resistance. The Thevenin resistance is just the input resistance on these two terminals. Now, how do we calculate it? First, we turn off all independent sources in the circuit. Here we have just this 6-volt voltage source. So if we replace him with a short circuit, we are going to get this circuit. So we have this circuit. Now, because we have this dependent current source here, we need to excite the circuit from the outside. We need to connect some external source. So let's connect this voltage source V0. And let's say that the voltage source has 1 volt. Now we need to calculate the current through this voltage source. And we will determine the Thevenin resistance by dividing the voltage 0 by current 0. We chose the voltage 0 as 1 volt. So now we just need to calculate the current 0. Let's use mesh analysis once again. This is current 1. This is current 2. We get that 5 times current 1 plus 3 plus 4 current 2 plus 4 times current 0 equals 0. Again, we know that current 1 is equal to half current x and current 2 equals current x. Now, if we substitute these equations into the first equation, we get that. Now we need one more equation. We need to determine current X somehow. So let's apply Kirchhoff's voltage law to this mesh once again, but this time we will just consider that the voltage here is plus 1 volt. So we get that 5 times current 1 plus 3 times current 2 plus 1 equals 0. So again, we substitute these two equations into this equation. We're getting that. Now we substitute this equation into this equation, and we get that the output current is 9 divided by 4 amps. And now we substitute into this equation. We know that the output voltage is 1 volt, and we know that the current is 9 divided by 4 amps, which gives us 444.4 milliohms. And that's it.